One mocha latte for here.
Thank you. This tastes funny.
It's the same way I always make it.
Now it's normal.
Huh?
And now it tastes like cappuccino.
I'm sorry. I will try it again. I don't know what's going on.
Oh no, this is fine. I had a hard time deciding what I wanted anyway. Now I have everything. Thanks.
You're welcome, I guess.
This season of the Bug Hunters Cafe is made possible by Softerific, Housepaw Media, and Manning Publications.
That's great, but I asked what you wanted to drink.
Oh, anything's fine.
Good, because anything seems to be what they're serving today.
Good morning, Boyan. Does your coffee keep changing flavors on you?
No, but my cappuccino doesn't have any coffee, remember?
Oh, right. Something's up with the coffee today. It's, everything flavored, I guess you could say. Coffee nut.
Sounds chaotic. Perfect match for a guest. Miko Pawlikowski, the author of Chaos Engineering and Software Engineering Lead at Bloomberg.
Chaos engineering always sounds fun to me.
A little chaos can be a wonderful thing.
And now you're just scaring me. And hello, Miko. Have a seat. The coffee is, chaotic today.
So we're here. Thanks for having me.
Can I get you anything to drink? If you want control of your order, avoid the coffee. Otherwise, it's everything.
I'll probably just stick to my kombucha. Just something that the pandemic did to me.
All right. I can get you one of those. We got a really good kombucha. They actually sourced it from the early 15th century, apparently. Don't worry, it's still fresh.
Good expiry dates. Nice.
Time travel is a wonderful thing. Oh, yeah, do you need a refill?
Absolutely.
All right. I'll be right back with both those.
So, Miko, I loved your book. It made me feel like I'm some super hacker. Especially with the parts when you're failing Docker containers with access to system calls and stuff like that. So can you tell me, how did you become so awesome at hacking and breaking stuff?
That's one way to open a podcast. Well, I'm glad that you enjoyed the book, and if it made you feel better about yourself, that's an achievement. So it all kind of started with just trying to sleep a little bit better at night. A few years ago, I landed on a project that was kind of greenfield, and we ended up choosing Kubernetes to run it, and then all of a sudden you have those dozens or hundreds of VMs, and you've got more containers running on them, and you want to make sure that things don't blow up where you're supposed to be sleeping. So that was the primary stimulus for basically going and trying to figure out how they can break so that they don't break on you. And later I learned I was supposed to code chaos engineering, and the rest is history. So, yeah, a sleeping aid, if you will. That's how I started with all of that.
I'm gonna follow your advice. Break things and then go to sleep.
Exactly. Keeps the doctor away.
Absolutely. Also, one thing, how did you get so good with Linux kernel? Because bunch of the stuff you did with Docker and others making storage fail and all that stuff, how did you do that? Is there a school for that, or how?
All right, so for everybody listening to that, I'm not that good in a kernel. I'm not a maintainer of anything. I just wanted to poke a little bit deeper. So, there's this saying that when you try to teach somebody something, that's when you really learn whether you know it well enough. If you can't explain it simply, you don't understand it well enough. So, ironically, a book is, in my opinion, a pretty good way to actually make sure that you understand these things well enough when you have to go and dive into things. So In the practice of running a platform, because that was my experience based on Kubernetes, when you got hundreds of people coming and deploying their code, you often find yourself in this peculiar situation when they come and say, hey, something's not quite right, or something's slow, or something stopped working for me after I deployed a new version. And you kind of have to fend for yourself and prove that there's nothing wrong with the platform or the underlying system, right? That they might have messed something up. And that's where you start developing this kind of survival kit when you need to dig a little bit deeper. And that's how you discover things like tracing their code and seeing what they're actually doing, whether it matches what they say they're doing. And, we live in this beautiful world where Linux is open source and you can just go and jump into the particular version of the kernel, read the code and see whether, for example, the metric that you're looking at, whether it's actually what you think it is and how it's calculated. So given all of that, with a little bit of time, you end up just digging deeper and deeper. And that's how you end up knowing some of these things. So in a single word, I guess just survival instincts, if you will. But yeah, it's a lot of fun. I'm sure you can appreciate that.
Yeah.
Sorry for the delay there. The Chaos Coffee is causing some problems with the equipment too. So there was a bit of a line. So Miko, here is your 15th century kombucha, and Boyan, here is your
Very much.
Thank you.
And got my got another cup of everything coffee because this is fascinating stuff. But speaking of chaos, so one thing I think I wondered when I first heard the term chaos engineering is why do you want to break things deliberately? I think I have an understanding now, but I want to hear from you. Why break things deliberately? Shouldn't we be creating stable software?
Yeah, I think this is probably one of the biggest problems with chaos engineering and one of the reasons why you often end up trying to call it something else. I think, when the folks at Netflix initially came up with this name, it was trying to be a little bit out of the beaten path and a little bit surprising. But for everybody else who needs an explanation, I think the primary kind of thing to understand here is that we don't increase the amount of chaos in your system. We try to decrease it by testing the failures that you expect to happen. When they happen, you know how the system behaves. So it's not increasing the amount of question marks, if you will, and it's actually decreasing that by purposefully trying things. And I have this conversation with people on a regular basis when they're like, hey, yeah, but what would I say to my manager, right? How do I tell them, hey, we should do some chaos engineering? And the conversation can go multiple ways, but one of the popular ones is that they say, oh, we've got enough chaos already, right? And to that you say what I just said, hey, this is not about increasing, this is about decreasing. And they're like, oh no, what do you mean by that? And then you go and say, oh, but by experimenting on the system, we can achieve a lot of benefits. For example, if we had an outage, we could treat chaos engineering as kind of like a regression testing tool, where we re-implement a problem that created the outage in the first place, and we verify that it's no longer an outage, that the system actually, handles it well. Which is like, at this stage, you should probably be getting a little bit of a buy-in from the manager, because you mentioned things like regression testing and avoiding outages, right? And then, with this newly acquired buy-in, you go deeper and you say, but also we can go further than that, and we can preemptively think of things that are likely to happen that we think we might be prepared for, but we never actually tested. Things as simple as whether we can lose one of the two data centers because we designed everything so that we can, but we never actually tested that, right? Or very, very kind of down-to-earth things like we're running out of CPUs or we're running out of RAM, and we never actually tested what happens at the limits there because we're continuously growing. And it would be good to have that kind of knowledge firsthand, right? So this is where your manager's eyes should get all big and the pupils dilated, and you should be getting them excited with that. And that's when you say, and also, by the way, you don't have to call it chaos engineering. You can just call it resiliency. So yeah, that's kind of like, what I prescribe to people who feel a little bit like they might be shut down immediately when they mention chaos engineering.
So I guess then the idea, from understanding you, of chaos engineering is that the chaos is going to happen anyway, so let's engineer it.
Yeah, exactly. These things are going to happen one way or another, and we should stop pretending that they won't. And, a lot of people think that if you're not the scale of Google or, I don't know, Facebook or something, you're not going to run into things like machines going down or, in general, hardware failure or human error very often. But the reality of that is that you will. You can just kind of pretend that you won't be. So it's better to be prepared than kind of try to sweep it under the carpet and hope for the best.
So it sounds like this is largely connected to high availability. Does chaos engineering have uses outside of server architecture, or is it very limited to just servers?
So I think that's one of the favorite things about this practice is that it can be anything you need it to. It's, if you think about it at the high level, it's probably more of a mindset really than any particular stack. You mentioned high availability. It's like an easy to understand example, and that's why I brought it up. But you can do it at any kind of level that makes sense for you. And this is something that I really try to kind of push with my book, because the way it's structured is that it builds up from like a single process. Like you mentioned earlier, playing with syscalls and seeing what happens when you simulate or fail a syscall or make it slower and things like that means that you can basically work with any kind of process, because that's what every and each of them has to do any meaningful work, right? And then it builds up higher, through things like JVM or things like the Docker containers, things like injecting things even in the browser on the kind of opposite side of the spectrum when you work with JavaScript, and see what happens where, what assumptions people build into the UI and whether failing one of the requests to the backend can make you end up with stale data mixed with new data that will eventually get saved, or disastrous scenarios like that, and other topics like Kubernetes. So basically try to show that it really applies from the ground up all the way to sophisticated, distributed high availability systems. And there's nothing that should be stopping you from having this kind of scientific approach to that by experimenting and verifying that things behave the way you think they do. And another side note to that is that a lot of people don't necessarily practice fuzzing testing on a regular basis. And fuzzing in the context of basically creating a lot of inputs for whatever you're testing, your function, your call, your remote call, anything like that, that are legal, but are not necessarily something that the designer thought of, just to kind of randomly, and this is where the randomness comes in, try to bump into code paths or, problems that people didn't necessarily think of in the first place. And this is also kind of like another facet that you see with chaos engineering. It can happen with like Chaos Monkey, for example. You would just take VMs up and down. So you would do it at the kind of high level, system level things. But you can do it at every level in the stack and kind of get, value out of that already. So yeah, the answer is basically wherever works for you and wherever you are, you can probably do some cool chaos engineering.
To me, chaos engineering was always a super glamorous profession. I think last month Dropbox shut down their entire data center to see what will happen. And when I hear that, my first thought is, I want to shut down data center.
Yeah, I read that blog post too, and I like how they kind of built up, and instead of showing this as a massive success, they kind of just showed the entire journey, how many years it took them to actually be able to do it without anybody noticing. But yeah, definitely go for it. I think you probably should prepare for it a little bit, because otherwise that might be the last chaos engineering experiment that you run at that company. But yeah, we design the systems and we make all these assumptions and we build all this functionality in there, but then there's so much of that that we don't actually ever try out. And we should.
So, but it sounds like there's more design work and thought that goes into chaos engineering than just being out behind the AWS data center with a pair of scissors.
Well, this will have to be very, very big scissors and very sharp too, I guess. But yeah, the thing is though that we already do that work, right? When you have the team of SREs, or whether they call themselves SREs, which is fashionable these days or not, we already do the work to try to make sure that what we build is reliable, right? And whether that work was done by you directly when the way you engineer the system, or whether you rely on some other component that is already handling, the high availability and thinking about the database, or the Redis or something. The work was already laid out and already done. So just kind of like going the last step and actually verifying that in the context of all of the things that we set up here, it still works and works as expected. It's fairly good return on investment. It's a last short step for humanity, but a big step for you as a person responsible for that being reliable. So yeah, like for a lot of people, when I mentioned the return on investment, that's another good reason, when you describe this to your boss, is that it's typically very good return on investment, because it's such a small investment and potential big upside. But yeah, sharpen your scissors too.
One thing I loved about your book is that you get a nice playground with virtual machine where you can break stuff. I really wish that more books came with something like that. Here's this thingy and you can now play with it. It's a very interactive book in that way. Quite unusual. How did that happen? Because usually you don't get that with a book.
Yeah. So, this entire thing that the book even happened was a little bit of an accident, because A, there was the pandemic and I had all this free time instead of commuting to the office. And B, just before the pandemic, the publisher reached out to me and they were like, hey, you should write a book about it. I was like, what? That sounds like a long time to do and a lot of work. But it was actually very satisfying. But the one thing, that I learned, if there is one thing that I learned as, kind of lead for an SRE team when you have a few but very sharp people, is that there's no point BSing anything. Like, they'll find out within minutes or hours or days eventually anyway. So you have to have receipts for everything you say, right? And so that's kind of something that I was trying to achieve with this book here. It's one thing to say, hey, yeah, believe me, or here's a command to run. But it's a very different experience when you can actually go and directly play with these things. And often the setup is much more painful than the actual experiment that you want to run. So having this VM that comes with the book, that has all the things kind of pre-installed and ready to go, is was one of the bigger kind of goals that I was trying to achieve here, so that you can play with that. And also, a lot of the good books about Linux are fairly outdated. Because it moves very quickly. So if the book is like from 10 years ago, it's basically old right at this stage. So a lot of the new technologies that kind of showed up with like eBPF and things like that, it was great to be able to kind of show people around a little bit, at least where to start and where to go from there in terms of learning. So yeah, it was definitely like one of the kind of bigger decisions here that made writing the book a bit longer and potentially a little bit more painful, but at the same time, everybody who actually bothered to download the VM has given me pretty good feedback on the fact that they can just jump in and play with things. So, yeah, I'm glad you liked it. That's how I know you actually read the book.
I was in a conversation with one of my colleagues at Mousepaw Media where we run an internship, and talking about the fact that there's a lot of times where we'll have someone who moves on, they finish the internship, or someone decides to leave or whatever, and historically it's always been somewhat chaotic when someone leaves. And the thought occurred to me that, well, I think there's some things we can do in how we manage a project that kind of go along the lines of chaos engineering. Like, for example, let's trade off tasks a little more often. Let's actually have to do handoffs between sprints. So that little extra chaos just helps ensure we're resilient for when somebody's going to be leaving. And that was the first time, that conversation was the first time it occurred to me that, maybe some of these principles apply even outside of just the code itself. This idea of incorporating or engineering the chaos that you're already experiencing.
Yeah, exactly. And that was like one of the reasons why I added the last chapter, which is engineering for people, that was inspired by some other work, by a talk actually that I heard a few years back. But basically the realization was mind-blowing for me when, it ticked in my head that when you treat teams as just any other system, you can apply almost all of the things that we apply to the systems on humans. Things like what you mentioned, like detecting bottlenecks is basically what you're getting at, right? If someone who is the only person who knows how this thing goes and works goes on a holiday, it's a problem, right? And through something very simple like rotating things, you can detect this kind of bottlenecks and you can resolve them quickly through documenting or just passing the knowledge in an informal way. So the fact that you can do these things on humans and a lot of that stuff that's not like high frequency, that's not, doesn't require millisecond resolution, actually works very well. That was an eye opener for me a few years ago. So I'm glad you picked it up too.
So let me get this straight. The coffee orders keep changing?
Yes, and the unicorn knows nothing. It's been happening to him.
I'll have to check whether we've gone through any probability fields lately.
So much for having a special today.
At least guests can still get 35% off any order from Manning Publications with the coupon code PODBUGHUNT21. It's good for anything, even Miko Pawlikowski's book, Chaos Engineering.
Now, if we can only find out who engineered this speed of chaos.
Does it happen with the tea too?
Now that you mention it, no. It only happens with the coffee.
I have an idea.
So, Miko, one thing that I'm wondering is, you look at a project and you think, I'd like to use this chaos engineering, I'd like to use this resiliency, but there's kind of this question of where do I start? How do you identify a bug or a potential situation where this would come in handy and be reasonable to implement?
Yeah, so that's also something I get kind of asked on a regular basis, and I can give you a few pointers. So one easy way to get started is what I kind of mentioned earlier, when you already had outage and you want to prevent that outage from happening again, and you want, your higher ups to give them something tangible to look at. And so this is kind of the context when you can just kind of re-implement whatever was the cause or the conditions that caused the outage in the first place. And you already identified an issue, right? That's just kind of like the lowest hanging fruit. Then typically when you look at the system and you talk to people about chaos engineering, they'll be like, oh, and they start kind of like having this very distinct laughter when they know something's broken, but they also know that no one bothered going down and kind of fixing that for the longest time. So typically, they already know what needs to be fixed. So this could be an impetus to go and actually fix it, right? But once you've kind of harvested the low-hanging fruit like this, then you have multiple approaches, right? One of the initially popular approaches was through the randomness. And this is where you get the nice things like catching emergent properties. Emergent properties is what we basically call the properties that we didn't design the system to have, but through the interactions of the components and the characteristics, they emerge. So, a typical example is your brain. Like if you look at the particular components of that, they're all simple, but just the interactions of the neural network in your brain somehow produces your consciousness and produces all the things that we are used to as human beings, right? Or another example is the heart, right? A single heart cell doesn't pump blood, but if you put enough of them together, all of a sudden they start, implementing the cardiovascular system for you. So in computer systems, we see that often too, and typically they're not exciting properties like emerging self-awareness. There will be things like bottlenecks and things like thundering herd problems and that kind of thing. So the randomness allows you to basically have very little investment of time. You just kind of set it and forget it, and it can detect things like that. It can detect problems through this kind of random failure. The kind of downside of that is that it's difficult to control, right? Because you make zero assumptions about what's going to happen and just wish for luck that you're going to discover something. And also limits where you are comfortable running that. That's something we didn't touch upon. But ideally, you would run this, everywhere. If you don't know what you expect, you're probably not going to be very confident to run it in your production environment, right? The third approach is to go and put your, white lab coat on and protective eyewear and glasses and try to do some first principles thinking. Right, there's some stuff that typically can cause problems, so it's always worth simulating that and verifying things work well. Typically at the congestion, right? If you have little RAM left, what happens? Does the application handle that? Does it crash? Stuff like that. What happens if you have noisy neighbors? If someone steals the CPUs from you, is it really behaving the way that you think? Is it going to slow down by the factor that you predict or not? Right? What happens when the networking gets a little bit lousy and you start having a certain percentage of TCP transmits? All the standard things that need to work well and need to be there. When you get to the borders of that, you get, potentially unexpected behavior. And then you kind of go up the stack, you go through the different sub layers and things that can go wrong. Kubernetes is amazing at many things, but it also introduces a lot of complexity that you often don't think about. So what happens when you rely on the healing that Kubernetes is supposed to do? Does it really take the X minutes that you expect it to take to recover if you lose a node? Stuff like that, right? And you slowly build up all the way to the application. And the application is in an interesting place because, on one hand, everybody can do it, right? You don't have to own a platform. You can build some chaos engineering into the application. And often, especially for like the distributed stuff, building chaos into the application is pretty cool because it's easy to do. You can, make it optional. You can compile it out if you want in production to, so that it doesn't touch the critical path. But it lets you very easily add problems into the application. And oftentimes, if you only own this application, you don't have the access to the underlying kind of lower level stuff. That's an option. If you don't know how to do the lower level stuff, you can already do simple things like, okay, so if I activate my chaos here on this kind of request with this probability, I'm just going to crash. Boom. That's like 5 extra lines, right? But you can already simulate problems and simulate what actually happens in practice rather than what you think will happen. So, kind of build all the way up to that and starting from the simple stuff all the way to like the more advanced scenarios and more advanced situations that are kind of a function of how you design the system and what you want it to have. So from no assumptions about the system and looking at the very low level stuff all the way to how the application is actually supposed to work. And this is, like the three typical approaches that I think probably cover like 90% of the cases for you right off the bat.
What's interesting is what I'm hearing is that it's kind of a different approach to handling bugs. So it's more along the lines of, instead of avoiding bugs and hunting bugs and preventing bugs, you're making your system be able to not be taken down by bugs as easily. So you still can find them and fix them, but when they inevitably manifest, like, we stop pretending that we can write bug-free code and accept that bugs are going to happen at every possible level. But if our code is written to be resilient to bugs, then a bug in a new feature, somebody, tries to divide by zero or, has some sort of floating point error, is not going to have some sort of catastrophic brought down the whole server consequence.
Exactly. Yeah, you got it exactly right. And, this is, at this stage, it should be very clear that this is not like a replacement for unit tests. And, once you get here, you don't need the unit test. You still need your unit tests and your integration tests and whatnot you have there. But this is kind of testing at a different level, like you mentioned, like the entire system. That what happens when you inevitably have at some point a thing that's going to crash a component, right? And this is something that currently we're not testing as well as we do. There are a lot of places now that approach, or at least try to get to like 100% unit test coverage, which is another subject. But not many of them are then going to put these components together and see what happens when one of them crashes. And, this is where I think a lot of the value from chaos engineering can actually be harvested.
By the way, this is a bit off topic, but you mentioned emergent properties. And I was reminded, I think the weirdest emergent property I've ever heard of was when I think it was Facebook was developing an AI. And the AI started talking to itself, wound up actually developing a language unto itself. And they had to shut it off because it was no longer speaking in English. It was now speaking in a language, like the two instances of this AI were actually speaking in its own language that it invented that they could not understand. So they deleted the AI because they're like, well, we have no way of maintaining this because we don't know what it's saying anymore. So they were a bit afraid of it going singularity, and they unplugged it.
Yeah, that's a good example. You basically rely on these emergent properties when you try to teach your neural network anything. So yeah, that's a good ballpark of what we're looking at. Yeah. So, do you do any chaos engineering at this stage, or were you kind of inviting me first for a coffee to see whether it was something worth doing to begin with?
Me personally, I'm not presently doing it. But that's partially because I'm in the middle of building a test framework. So this is something that I was looking at and thinking, this is something I actually want to build in, because you mentioned fuzzing, and there's a lot of problems with C++ testing that just kind of aren't handled well. The framework I'm helping build is on the idea of actually baking the test into prod instead of having to have an outside test harness. So because we're building the tests into production, they're not actually loaded until they're wanted. But these ideas of being able to verify test benchmarks continue to pass on production systems, on end user systems, is kind of the principle. And so as I began learning about chaos engineering, things I've read, etc., on, some of your work, and then I started thinking, this is something that maybe not to a massive degree, but to some level could be built into this framework, at least in the form of fuzzing. Like the idea of let's throw within given the parameters of a particular data type, because otherwise you just get a boring old compiler error. But within the parameters of a data type, let's just throw garbage at this and see what happens. And the idea of like, okay, these are the acceptable possible outputs, and then be able to have the test fail when something gets thrown in and you get out something other than one of the possible expected outcomes. It's like, okay, well, we could either throw this exception or return a valid output. Oh, we threw that exception? Oh, went in an infinite loop? Okay, well, now it's a failure. The idea of kind of playing with some of that, something I've been turning over in my head for a couple of days. How about you, Bojan?
I used it on one of the projects for my client. They're doing some blockchain development, and it's quite fun. Honestly, I do prefer breaking stuff. But usually when I'm working with clients, their budget for chaos engineering and resilience does not exist. It's almost like the same thing happens with security. You have budget of security before data breach that doesn't exist, and once you get your first data breach, then you suddenly have a huge budget for that. And for me, usually when talking with clients, resilience is probably somewhere in that ballpark. And to me, it's always been hard to explain people that you need security, you need resilience, and that's part of the product. While most of the clients just want product as we're going to pay you the least amount possible for a minimal number of features that we need.
Tiny.
Yeah, well, for a lot of people, that's the reality. But I think, one of the things that kind of is becoming clear in my head over the last few years is that initially it was a lot of this exciting stuff, oh, Netflix tech blog, and let's break all the things, and let's do it in production, all of that. But in real life, it's the smaller things that kind of creep more into people's just, sprints, boards, and backlogs that actually make the difference slowly and in a much more boring way than, oh yeah, we blew up our production environment yesterday. Things were awesome. So, and I think that's probably the case with, a lot of these new technologies anyway, right? The VR is not exactly what we were picturing 10 years ago, but it's slowly creeping in. When I think about Kubernetes, how exciting it was, and how we've been collectively trying to make it boring so that it works more in the kind of enterprise setting, it's probably the same forces at work here. So, yeah, kind of makes sense what you're saying.
Yeah, it's very hard to develop good software because it's kind of expensive, and most people just want okay software.
Yeah, just good enough. Yeah, and the reliability gets chopped more often than people want to admit.
Yeah, and I work a lot with AWS, and it's very hard to explain to people, okay, we're going to double your monthly bill now in order to have a fallback architecture. They're like, no, let's just keep it at one.
Well, I was talking to someone the other day, and they were talking about how they were working with a client, and this client was not all that concerned with the fact that they had PII exposed. They had some major personally identifiable information exposed, and it was really easy for someone to get to. And my friend's going, I'm trying to explain to them, this is important. This is a big deal. No. It's okay. We haven't lost anything yet. It's like there's a lot of kind of backward thinking, like only thinking about, well, it has happened. Isn't that called the gambler's fallacy? That past patterns predict future outcomes, and it's amazing how many software managers fall for gambler's fallacy, or how many times we fall for gambler's fallacy. Well, it hasn't happened yet. I mean, raise your hand if you've actually taken a backup of your computer in the last 48 hours. I haven't. Probably should. Really, definitely should, but I haven't.
Yeah. And, currently, if you're running like a platform, the CVEs are coming like literally every week. There's something new that needs to be patched. So I think over time, we're probably going to increase the investment in that, but it's still not obvious.
So one thing we always like asking is, what's one of the strangest bugs you've encountered? And we'll settle for one of the strangest bugs that you have prevented would be acceptable as well.
The weirdest one was definitely, it was maybe 3 weeks ago. I've been trying to track down an issue where a machine supposedly ran out of memory. And when you look at your free, you can see that it's actually being used, but then you can't see what's using it. So when you try to match to the processes that took it, you can't see it. So that's where slot memory is basically the next thing to look at. And this machine had a whole lot of it used. It was like a half a terabyte machine, and it was using like 450 gigs of memory for the slab allocator. That was the first one that I actually went to try to understand how the slab allocator works. And I'm still trying to figure out what it was. So if anybody has ever found an issue like this, it was a recent kernel too. I think it was 5.14. If anybody's found anything like that, please let me know, because as of today, I have still no idea how I ended up with 450 gigs of slab memory allocated. Any ideas?
I wish I knew. Yeah.
Okay. Well, definitely a weird one.
Yeah, we'll ask around the cafe and let you know. Somebody has probably figured it out. Probably you from the future.
Nice one. Fair enough.
So let's scale it back a little bit too, because a lot of people hear about this, and we've been talking a bit about this already, but a lot of people hear about chaos engineering and they're thinking larger projects. What about the guy with his little side project? He's doing, he doesn't have a lot of users. He doesn't have maybe he doesn't even run it on a server. Maybe it's just a little application or a little tool or whatever. But just to kind of reiterate, what would that person do if they wanted to introduce resiliency into something that's right now is already very small, very well contained, very few users, but thought, I'd like to introduce this in here either for practice or because, well, I have big aspirations. How do you start when it's still a very, very small product and you don't see the cracks because you don't really have any users?
Yes, I think one of the kind of natural places where it fits nicely is the CI. And, we try to, even if you have a side project these days, you can set it up for free with like GitHub Actions or something like that fairly easily. Some people are joking that the GitHub Actions are now the nicest serverless platform that you can get for free on the internet, which is probably the case when you think about it. So that would be like a natural place where I would probably look first. But if it's a side project, it might be also about, the learning opportunities, right? In that respect, I think that just playing with chaos engineering, kind of trying to see at the different levels whether you have enough knowledge to apply and design and execute these experiments is probably going to be fairly satisfying, and it's going to teach them quite a bit of that. So, if they don't have the CI, there's no excuse to not have it at this stage. And that's where you can implement quite a lot of that. And especially, I keep saying GitHub Actions, but it's actually really good. You can basically spin up the VMs with like a simple YAML, do your experiment, verify the outcome, and build up on that, all for free on Microsoft dollars. So, yeah, that's where I would start.
Yeah, I think we haven't asked yet, but now I'm becoming curious. How did you even wind up doing chaos engineering in the first place? Like, what led you into this?
Well, that's what Boyan started with. He was like, hey, why? And the too long didn't read version of that is that I needed to sleep better at night, right? And the more you find of these things, the less you're being called, and the less you're being called, the better quality of your sleep. So it was really just like kind of organically evolved into a mixture of, okay, this broke, or some, dependency broke, and our system was incapacitated, so let's prevent that from happening again, and then kind of going a bit further with that and trying to predict the things in the future. That ended up being like this collection of dodgy bash scripts that we later turned into the tool called Powerful Seal, and we open sourced it. That basically, in a little bit more elegant of a way, lets you describe, okay, so these are the conditions, this is what the experiment looks like, and this is the verification that things continue working. That was the primary driver. And, because at the time, Kubernetes wasn't, I guess, as well understood as it is now, it was just to make sure that, it doesn't break up too often. And later, I learned that this is supposed to be podcast engineering.
So if you weren't doing this, if you weren't doing chaos engineering, what would be your area of interest in tech?
I think kind of looking back at what I actually gravitated towards, I've done a lot of distributed systems, and I think the primary driver that actually motivated me to do that was that they're so annoying to work with. Like, they're just a level harder than non-distributed. At the same time, if they increase in scale of pretty much everything, they're becoming the bread and butter of doing anything, right? And it's one thing to use a database or like database as a service and just rely on that. But if you don't understand how it works behind the scenes, at least at the kind of high level, and what the limitations are, it's a little bit like, driving a car without looking at any of the instruments, right? Just kind of going for it. So I think that's kind of what has been driving my interest in this. A lot of the stuff kind of repeats itself, when you have the same kind of issues with all of them. But at the same time, there's enough of the uniqueness in the different solutions and the different pieces of software that you work with that it kept me interested. So I think, if I didn't kind of go down the chaos engineering route, I would probably have gone even further with the just distributed aspect. Ironically, because it's so annoying to work with. So, a little bit of healthy masochism.
Yeah. Any parting words?
Well, for anybody who's kind of on the fence and thinks like, oh, this sounds cool, but I don't have the expertise or I don't have that complicated of a system, I would say don't be shy and give it a go and try to see whether this might be a good fit. At the worst case scenario, you're going to learn a few new things, and that might come in handy at some point. At the best case scenario, you're going to find some issues that are going to save you a lot of trouble or potentially dollars. So go for it, would be my parting words. And enjoy some 15th century kombucha if you can.
Thank you so much.
Thank you.
We would love to have you here sometimes in the future.
With a time machine, that shouldn't be a problem.
Maybe we can get you in touch with future and past versions of you. So you get 3 guests for the price of 1.
Nice, yeah. I'm free last Tuesday.
There you go. Let's organize something around that.
That sign on the side of the road that I saw once that said time traveler meeting here last Tuesday.
Exactly. All right, guys. Thanks so much for having me. That was great.
Bug Hunters Cafe, this is Jess. Of course, we're always open 24/7 at bughunters.cafe. You can also find us on Twitter as bughunters.cafe. We like the music too. It's provided by audionautics.com. We have a link on our website. As a matter of fact, you can win a copy of Chaos Engineering by Miko Pawlikowski. For your chance to win, just retweet our Twitter post about it, and then follow Bug Hunters Cafe for the announcement of the winner in a few weeks. See you soon.
I found out why the coffee orders keep changing randomly.
Yeah?
Instead of getting the coffee beans from the usual supplier, the unicorn bought them off of Jaime, the taco merchant in the back alley.
The Chaos Taco guy?
That's the one. He said they're chaos coffee beans. It doesn't matter how you brew them, every sip will be a different coffee drink.
Does he have any more? Most of the customers liked it.
Plenty. I say we add chaos coffee to the menu permanently. Meanwhile, I have the unicorn go get some regular coffee beans for our less adventurous patrons.